We're almost there, everyone. We're almost there to your Saturday happy hour. But we've got a few more talks, and I'm super excited for the next talk. It is called Chain Abstracted Async Apps, though I think there's a version 2 of the name. So please welcome Adair Kelley, co-founder of Abstract Money. Round of applause.
Oh, that's fine. Hey, everyone. Thank you so much. Hi, I'm Adair Kelley, co-founder of Abstract Money, and I'm here to talk about some really cool application architectures. So, who here knows chain abstraction? Has anyone, raise your hand if you've used the chain abstraction solution in the last, 2 weeks or a few months? No? Okay, well, chain abstraction unifies your balances, allows you to transfer assets across multiple different chains quite easily, and swap any asset in your wallet for another. So the GIF, this is supposed to be a GIF here, but you'll see that my balance of USDC is unified across all of the chains and hidden from me as a user. However, chain abstraction is an illusion. So chain abstraction solves a problem that most crypto users have been experiencing for years. The fact that you have to get gas tokens for every new chain, you have to actually care about which chain your assets are on. Is my USDC on Polygon, or is it on ETH, or on Optimism? Same with any other token. It's quite cumbersome. And in the past year, we've seen a number of chain abstraction solutions like Particle Network and OneBalance and all of these wallets that unify this experience. However, it comes with quite a few limitations. If you try to use these unified balances to build cross-chain protocols, you end up with fragmented liquidity and the harsh reality that these chain abstraction solutions centralize the execution of your actions on-chain. So, how does chain abstraction work? If you look here in this example, we have an Omni account. This is actually a diagram generated by the Rhinestone team, so thank you, shout out to them. We have an Omni account, which is a universal account that works across multiple different chains. When I go to use assets in my Omni account, I will execute those actions through the orchestrator. So let's say that I have USDC on one of these chains, whether it be Ethereum, Optimism, or any one of these EVM chains. I have USDC, but I want ETH. So the way these wallets work, it'll unify your balance across each of these chains. It'll know that you have USDC. You tell the orchestrator, someone who coordinates actions across multiple chains, that you want ETH and you have USDC. This will broadcast the message to the orchestrator. It'll figure out the best path to get you your ETH, give you your ETH, and then provide a proof that it gave you ETH to withdraw your USDC. So as an end user, at the end of the day, you get ETH for USDC. But if you try to use this for any applications or protocols, the illusion starts falling apart. So if you think about yield aggregators or cross-chain lending, where you have assets on Ethereum and you want to borrow them on Optimism, or cross-chain governance, when you want to create decisions between multiple different chains, or even investment strategies, where you hold assets on one chain, move them to another to, essentially act as another yield aggregator. You cannot use these chain abstraction solutions because the liquidity is not abstracted. It's completely fragmented across all of these chains, despite what the user interface tells you. So let's take a specific example here. Does anyone know about trend following? If not, trend following looks at the previous price history of an asset, and it generates a signal based on the strength of the price movements of the asset. So if Bitcoin's been trending up, it's a very trendy asset, so it's probably going to continue trending up. So if you implement a trend following algorithm, it'll see that and give you a signal that says, hey, Bitcoin's starting to trend up. Let's increase our allocation from 0 to 25%. And to implement these algorithms efficiently, they're generally done on Perpetual's protocol so that you can have leverage to meet a certain target volatility. And your collateral stays on that chain. But this is kind of inefficient. If you have just USDC, you can't collateralize a yield-bearing asset, and so but since you have access to leverage, you can use less of that asset and actually use the unused excess collateral and put it in a yield-bearing asset. But herein lies the problem. even though we have chain abstraction, we have many chain abstraction protocols today, if you try to build a vault that holds a hyperliquid position and then a yield-bearing asset like SUSDE, you run into a big problem, and that is that the liquidity is fragmented across the chains. At the bottom, you'll see the trend BTC signal can go from -1 to 1, which will be multiplied by the leverage to implement trend following. So what are the requirements for a trend following vault? One, it needs to be able to rebalance your assets across multiple chains. Here we just have two. We have Hyperliquid and Ethereum. And those rebalances will be calculated based on the signal for the day. Second one is it needs to calculate the value of your vault shares of the entire vault across multiple chains so that it can give you the proper value of those shares when you go to purchase shares in the vault. Finally, processing those shares, which is an asynchronous action because trend following is best implemented on a 24-hour interval and cannot happen synchronously, or you end up with bad execution. Every single one of these actions is asynchronous, and many applications in Web3 are fully synchronous, which, yes, it offers novel mechanisms like flash loans, but this is not a case where that applies. So if we look at the cross-chain rebalance, you start by calling rebalance on the vault, and what will happen, it'll calculate the number of assets it wants to send or request from a remote chain. So it'll send that request via a messaging protocol to that chain, it'll get a confirmation, and then you'll get the asset back. What you don't see here is the acknowledgement or the failure case on this action. When you start building asynchronous applications, you start increasing the complexity and increasing the number of edge cases that you have to take care of as a developer. And how about share value calculation? It's the same story. You send an execute message across another chain to query the value because you actually can't query the query states across multiple chains, at least right now, given the current state of EVM. Then you get the value back, and then you calculate the rebalance. Okay, that's cool. It works with two chains, but what about with 3? So let's say that we wanted to improve our risk-adjusted returns in this trend-followed Bitcoin vault. Many of you may not know, but gold, even though Bitcoin is supposed to be digital gold is entirely uncorrelated from Bitcoin. So it's a good asset to add into your portfolio. If you combine Bitcoin and gold, you'll have better risk-optimized returns, but you're also adding another chain to this mechanism. So now in a rebalance, you'll be sending and requesting assets from Plume, or Hyperliquid to Plume, and then Hyperliquid to Ethereum. And this complexity increases with every other chain that you add. Okay, yes, it's a completely contrived example that would probably involve multiple vaults, but it's a good one for this demonstration purposes. Most of these chain abstraction protocols, they operate by using intents. And intents, as mentioned earlier, just allow you to say, I have X, I have USDC, and I want WETH. In the case of this vault, if you're on Plume Chain, you can say, hey, I've got 15% gold, but I want 25% gold. And you can broadcast this intent as the vault, and some intent solver could come in and solve for that intent, providing the liquidity where you need it. But what happens if this vault holds over $100 million, or some arbitrary amount where the solvers aren't able to actually solve for that amount of liquidity? What solver has this size? The answer today is none of them, by the way. So let's take a step back and think about what cross-chain apps, what features that they require. So one is they require cross-chain messaging. You have to send requests from one chain to the other, and you'll get an acknowledgement or a failure case once you send that request out. These failure cases or these acknowledgements, you do also have to persist. You're developing a state machine, and it's not, across. It's not on one computer, so you don't have a centralized entity that can handle the state for everyone. Next, you need to recover from failure cases. What happens if you were rebalancing between Hyperliquid, Plume, and Ethereum, but the Plume rebalance call actually failed? What do you do with the rest of the rebalance? Do you retry it? Do you, at which point do you determine that the entire operation has failed? Okay, and these last two are actually something that is very common in Web 2, but hasn't been implemented in Web 3, and that is authentication. So application authentication, allowing you to register different services on different chains. For example, my Vault service on Plume and my Vault service on Hyperliquid, as well as name resolution. When you have a cross-chain application, you don't actually always know the addresses of the services that you're interacting with on the destination chains. I'll give an example from the Cosmos ecosystem, because IBC is a widely used bridging protocol. When you bridge assets from one chain to another, you end up with a denomination specific to the path by which you bridged it. So if you bridged an asset from Hyperliquid to Plume, the asset would be Hyperliquid Plume USDC, or whatever it is. It's not going to be the canonical variant. Yes, intents solve this, but if you're building an on-chain protocol, you'll need to be able to resolve those names on-chain, on demand, at quote-unquote runtime. So you send a generic message across the chain to rebalance for USDC. So let's take a look at cross-chain architectural patterns. One is the hub and spoke model. This is used by Axelar, it's used by Zion, and it allows for one centralized entity, even if it's running on a decentralized network, to act as the orchestrator to perform actions across chains. The second one is intent-based. This is the model that's used by most chain abstraction wallets that you use today, and is quite effective, at least at moving small amounts of liquidity across chains. However, it has some limitations, as I will go ahead and address. Finally, the one that's actually kind of interesting is a mesh application. So a mesh application actually shares state across every single participant, every actor in the state machine. So if you want to yell out the one mesh mesh architecture implementation, it's probably going to be blockchain. So every blockchain comes to mesh consensus, depending on the consensus mechanism. If we look at hub and spoke architectures, you have a decent amount of benefits. You get deterministic execution. It's really easily verifiable because you have one place that's managing state on behalf of multiple chains. It's error resilient because you can run these actions sequentially. You don't have to deal with asynchronicity in terms of state management, but it offers a single point of failure. And as we saw with the chain abstracted wallet in the first example, you are actually executing your action through a one point, and you're constrained by that one point's throughput. So what about intent-based coordination? This generally happens off-chain, where you have a solver like solve for the intent that you propose, and this has very high capital efficiency because it's just an off-chain entity. You don't need to bridge things. You don't need to unwrap your assets, and you can execute this independent of the time within your application, because you can broadcast an intent, and maybe it gets solved a month later, maybe it gets solved in the next few minutes. It's also resilient to solver failures. If someone was unable to fulfill your intent, then some other solver will be able to solve it eventually. Okay, the big limitation with intent-based protocols is that they completely rely on economic incentives. If you don't have tokens moving alongside your message, there's no incentive for the solvers to actually solve it. Let's say that you are trying to develop an interchain session key application where you had one chain that registered session keys on remote chains. This protocol is actually not able to be intentified because there are no tokens associated with those actions, and you need to verify the finality of the origin chain. So you end up with also non-deterministic execution. You don't know what the message is once you execute it, what it's going to be. Okay, so let's go back to our BitGold plus Vault and look at the design pattern for this. So the best executor for rebalancing assets is going to be the intents, or if your balances in the Vault are over $100 million, probably best to be done on the protocol level. Same with calculating Vault shares, and then processing those shares is actually going to be done completely locally. But not one single pattern that we looked at before, the hub and spoke or the intent model, is sufficient to build this type of application. You need to combine them. So, okay, universal accounts. let's go back to these. So if you think about universal accounts, they allow you to move assets between chains very easily via intents. They're also quite special because you have, at least on EVM chains, the exact same counterfactual address on every single chain. That means that you already have authentication baked into these accounts, and you can trust that if you get one address on one chain, that a message from one address and is the same address on your local chain, then it is the same actor, it's the same contract. What most people don't think about is that you can actually build apps on top of these universal accounts. So if you use the universal account as an authentication layer, you can extend that account, like a 7579 account, with a module that enhances the functionality of that account. And that module can execute messages which are authenticated by another contract that checks the sender and the receiver on the destination chain and communicates via an interchain messaging protocol. This can be IBC, it can be Hyperlane, Stargate, any one of these messaging protocols that we know and love. And so what this means is if we were able to build a vaults protocol on top of universal accounts, we would be able to use intents to solve for the rebalances, and then we'd be able to write custom protocol logic on top of that account with baked-in authorization to do the share calculation and the order execution, which is actually quite cool. And yes, this type of model scales very well across different chains. You have the authentication, and you can send a message from any chain to any other chain, and it's all authorized via the hub. So something that's not mentioned on the slide is that this middle account here is acting as the client and the hub, and these right and left accounts are actually the spokes for this different application. So we have a hub and spoke model that also uses intents. So if we go back to our problem at the beginning of the presentation, we know that yes, chain abstraction unifies balances, or allows you to transfer any asset to any other chain, and swap any asset for any other. But yes, it has limitations, though if you combine it with a protocol level logic installed on those universal accounts, you can actually build amazing cross-chain protocols, solving for the fragmented liquidity and decentralizing that execution. This is actually something that we are using at Abstract Money to tokenize institutional investing strategies called factor assets. We use orchestration, which is the term for the hub and spoke model plus intents, to allow for the creation of single vaults that operate across multiple different chains with the exact same address, with all of the logic being executed on the universal accounts upon which the vaults are running. So if we look at our trend BTC signal here, we can see there's an off-chain strategist providing that signal to the vault. The vault will rebalance them across a perpetuals DEX and allow for the transfer of those assets to any chain to get us the best yield based on our capital in the vault. These are asynchronous, multi-strategy, multi-chain vaults, and they're super duper cool. Would love to chat. If any of you want to chat about this after the talk, happy to, because they're cool. So yeah, come build with us. We've been building abstract or developer infrastructure for around 2 years now, and there's a lot of really interesting applications that you can build, and in my opinion, every single application going forward in the next few years will be asynchronous. It will be multi-chain as we move towards an application-specific world. So thank you very much. My name is Adair, and yeah, happy ETHDenver.